Hi, everybody. Can you hear me? Well, you can't answer. Welcome to our event, our meetup today, Flutter Festival. Cool kids use declarative toolkits. I told myself I will warm up for this event to repeat the title like 5 times. Okay, I will try that now. Cool kids use declarative toolkits. Cool kids use declarative toolkit. Okay, I stop right now. It's not that easy, but I also won't spend a lot of time moderating here. Let's welcome our first speaker already. Maya, are you there? Hi, Maya.
Hi.
Hi, nice to have you here. Thanks for joining. Just a few words about yourself. So you're an Android engineer at Luno. So is it the Luno, the cryptocurrency Luno, or okay? So Google told me correctly. And you work as an Android engineer and primarily with Kotlin, right?
Yes, so native Android using Kotlin. We don't use Jetpack Compose yet, but I'm always experimenting and tinkering with new APIs and things. So I was playing around with that on the holidays.
Great. And when I asked you to drop me a few lines about yourself, you said, okay, your first computer was an ZX81 and you didn't have any internet yet. So what is a ZX81 actually? I don't know that.
It's a small little computer that plugs into a television. And it runs BASIC. It was running BASIC. It was before the time of laptops with DOS. It was somewhere, well, 81 was when it came out. I got it a bit later. It's a Sinclair computer. And so that was the first language that I learned was ZX81 BASIC. And there was no monitor. It was a little plastic computer that you plugged into a television screen. And the data was stored on a tape deck. So you had a little tape deck next to the side and you would your programs would be either in memory on this tape deck. And if you wanted to load your program, you literally played the tape and it would go like that. And the data would be transferred into the computer.
Great. Okay. Yeah, I think my first computer was a bit later. It had like 120 megahertz and was an Intel already. So
yeah,
there's a huge difference.
I had 1K of RAM.
Okay. All right. If you're good to go, then I will just hand over to you, and I'm happy to hear your talk, which is about Jetpack Compose and animations.
Yes, I'm going to just switch my screens around a bit. So let me switch my screens, and then you can put my slides up. Okay, great. So I'm not going to say the title of the talk tonight, Cool Kids and Toolkits. So my talk is about Compose Animations as speedrun. So what I'm going to do is I'm going to show you quickly how Jetpack Compose does animations. So it's a whirlwind tour of Jetpack Compose Animation API. So I'll also go into the API and we can have a look at how the API fits together with Jetpack Compose. And who am I? I've already been introduced. I'm Maya Grotepas. I'm an Android engineer at Luno. And if you need to speak to me, there's my Twitter handle on screen. Or if you just search for Maya today, you'll find my GitHub repos and my GitLab repos. So let's just see if I can get the next slide. Okay, so as a practical background for this animation talk, I built a little demo app so that we can see practically how the animation works. And I just built a simplified crypto exchange. It has a screen on which you can buy and sell things. It's got a progress indicator for when it's fake, all of it's fake, but when it pretends to sell or buy Doge. And then there's also an order book screen, which you'll see over here. So this order book screen here with the prices. And then there's a little extra, which is like a Twitter card, which has a tweet and then a progress indicator for when it's supposed to go on the internet and fetch a new tweet. So that's the app I'm going to use as my examples. So now let's take a step back and think about animation for a moment. So any animation in any platform, or even if it's on TV or wherever, there's something that changes over time. So time or frames, so this is the frames that get updated. And for us to see movement, something needs to change. So for this, for instance, this would be the size of this little ball changes, the color changes, the position changes, the alpha might change, the shape might change. And if this changes over time, that's how you see an animation or you see movement on the screen. So, and also to prepare, there are some questions around this. Like, I mean, if you're comparing different toolkits, there are kind of things that I'm thinking about. For instance, where's the draw loop? Where's the piece of code that runs in a loop that's going to make this time and these changes happen? Can I customize these animations? Do I have to figure out the interim steps in between? And typically, if I'm clicking on something, how do I, like if a user clicks something and triggers an animation, how do you trigger the animation? So those are the kinds of questions I've got in the back of my mind while I'm looking at the API. But let's take even another step back and let's just get a quick overview of how Compose works. So the crux of Compose is there are functions. It doesn't work with object trees. It works with functions because it's composable. We're using composition over inheritance. And so there's like nested functions. These blocks represent a function, and you'll have some other functions being called from this function. And these composable functions, they can either have state or be stateless. Now, state is quite an important concept within Compose because how it works is your state gets passed into your composable function, and also the events come out of it because a click handler gets passed in. And the state that gets passed in here is immutable inside here. And if the state changes on the outside, and then the state gets passed in again. So if I'm looking at this graph, you might have something like a view model, or you might have something like Jetpack Compose's remember function. The state gets passed in here, and these sub-functions will get pieces of the state that they need to show the UI. So if I'm looking at this composable function, when you're coding it up, this is what you would do. There's a pure Kotlin function. The convention is to use a capital letter here if it's a composable function. You annotate with @composable, and then you pass some parameters. One of the things you pass in is the state. This can be any object or any value going in. And then what this @composable does, it's an annotation, but it doesn't actually go through the annotation processor. What it does is there's a compiler plugin, and the compiler plugin actually passes in a reference to the composer object as one of these parameters. You don't see it, but it happens at compile time. The interesting thing about this composer object is that it has memory structures. It has a thing called a slot table. It knows about the state. So this state coming in here, this composer is aware of the state. It can see, it's got flags and points in the code where it can see when the state changes. And then when the state changes, it can decide to recompose, which means it calls these functions again. The reason I'm going on about this is because all of the animations that you do in Jetpack Compose, you actually drive through the state, through changes in the state. And then you let the composer do the recomposition to get the movement or the changes for the animation. The other thing I want to mention here is this modifier. So each of the composable objects typically could have a modifier. And a modifier is just an object which modifies what happens inside the composable function. And then a composable function returns unit because it doesn't make the view system draw the view things on the screen. It's just a declaration of what you want on the screen. And then the composer here with other libraries are hooked into the view system and knows how to make those views be visible on your screen. So it's just a declaration. You're just declaring what you want. And then the composer is the magician in the background that will make the views appear and decide when you need to recompose because of the state. So that's a little bit of compose theory. Now I'm going to jump into the APIs. So this is the animation APIs. I'm going to give you a quick tour through them just to get a sense of what you can do. And then we're going to have a look at some code examples. So I know in Flutter, there's some intrinsic animations and extrinsic animations. And I think these functions that I'm going to show you here now, these map to the intrinsic Flutter animations. The thing with Flutter, though, is they use objects, and we are just using functions. So in the animation API, the first thing I want to mention is this animated visibility. So what I've got here, there's nothing here. There's a bunny, and then there's nothing. So this is like if you imagine a magician, and there's nothing, and then they pull a rabbit out of a hat, and then they make the rabbit disappear again. So if you have a composable function, and there's no composable function, but you want to make the composable function appear, like the bunny appearing, there is another composable that you can nest this in called animated visibility, and then you can control how quickly or how this bunny appears. Okay. The next one, another intrinsic one, is one that's crossfade. So here the picture is, I've got a heart card or a composable that represents a heart card, and I've got another one, the diamond card, and I want to make the heart card disappear, and I want to make the diamond card appear. So it's like a crossfade. So this one disappears and this one appears. So you've got two composables and you want to crossfade across the two. And the composable to use for that is crossfade. The third one is I've got a composable and it's got some other content. The content here is not composable. The content here is just something else. In this case, I've got a rose and a coin. So you can imagine a magician with a rose and a coin in their hand, making the rose turn into a coin. So if it's the content of the composable that you want to animate, then the method to call is animated content. And then the last one of these is, this is a modifier. So you can add this to any composable that takes a modifier. And what it does is if the inside of what's going to be shown inside the composable is a certain size, and then the size changes to something else, you can animate the size change. Okay. You don't have to remember any of this because I'm going to show you some code examples, and there'll be a Git repo to look at afterwards as well. So now let's dig a little bit deeper into the API. And the next sort of slightly more complicated thing that you can do is if you've got one parameter that you're changing, right? So I'm changing green to red. It's only one thing. It's a color that I want to change. So here there are a group of functions which are animate something as state. So this could be animate color as state, but there are other values as well. It could be a float. It could be a DP. There's a whole family of functions like this. And what this function will do is it will make the value that you want to move between be inside the state that the composer knows about. So that value will be updated in the state, and then the value can be used as a state into a second composable, which will then animate it. And the animation between, say, green to red will be controlled by this method, updating the state. But now what if you want to change two things at the same time, but they need to be coordinated? So maybe you want to change a color and you want to change a size. So you want to change from blue to yellow and you want to change from small to big. So what they have is a thing called update transition, and this update transition can take children, and the children will then be coordinated so that the starting size, ending size, starting color, ending color is coordinated by this update transition. And then you again can just get the values from this update transition's children and pass that in as a state parameter into your composables. So now this is useful if you want to click something and you have a transition from one state to the next state, like from a pressed state to an unpressed state, or from a visible to an invisible state. But sometimes there are animations that loop, they're a continuous loop. And so for that, this is also a transition. So it also has children, and it starts as soon as the composable gets composed. It will start and it will either run once, or you can get it to run in a loop. So you're using this kind of transition for your looped animations. And so at the bottom here, I've got some more deeper layer animation API things, but I'm not going to talk about those tonight. Otherwise the talk would be too long. So now I want to go back to this graph. So this graph has a particular shape. Now, if these balls, if it was higher, you would get a different looking animation, or if this was a straight line like that, this animation would look different. And in Jetpack Compose, we can control what this graph looks like when we're animating. And now I'll show you what that interface looks like. So all of the animations that I showed you before, they've got defaults, so you don't need to set them, but they all take an animation spec. Now, an animation spec, now here's the thing that could be confusing. With Flutter, this animation spec, I think they call it a tween. Now, in Compose, a tween is something else. I'll show you what the tween is. So this is an animation spec that controls that graph for the animation. If you don't set it, you're going to get a spring, which is going to have a kind of a physics-based spring. You can modify this, but the default is going to be a spring. If you don't want a spring, you can get a in between. So what we call a tween here is equivalent to the curve that you can add to a tween in Flutter. But you'll see that in the Flutter talk when we get to the Flutter talk. But a tween here is a kind of a curve for that animation spec, and a tween is a linear interpolation between two values. The other option is if you don't want a physics-based or a linear interpolation, you can set keyframes. So what the keyframe does is it says it gives a value and a timestamp. So you can set the timestamps and actually build up a nonlinear graph, a curve for this. And it will work out the in-between values and make sure that it'll be, say, at 0.2, the float value is 0.2. So if this was, say, what could this be? This could be like alpha. So you could be at 0 alpha, 0.2 alpha after 15 milliseconds, 0.4, 0.4. And so you could set up, say, a keyframe. You could set up a nonlinear graph like that. And then this animation spec, oops, too quick. The animation spec can also have some specification of how to do the repetitions. If you want to do an infinite loop, you can go forward and backward or reverse and control the infinite repetitions like that. So now let's look at some examples. So if I look at my little app, I'm going to give you a URL in the end, which is where the repo is. And each of the repo has a pull request with that number for each of these examples. So what I wanted to do here is you can see there's a tweet card composable, and there's a progress indicator. And if you click on this one, it must crossfade to the progress indicator. And when the progress comes back, it crossfades back to the tweet. So let's look at what the code looks like. So in here, this if and else is what the code would have looked like if there was no animation. So it's got some other flag that's coming in as a state, which says either it's loading or it's not loading. So state variable coming in. If it's loading, I show the loading indicator. If it's not loading, I show the tweet card. Now, to add a crossfade, all you need to do is use this crossfade composable that I showed you from the APIs, and you literally just wrap your normal code with this crossfade. And there you can see, okay, we're saying that this state, the state that does that the crossfade responds on, can come in from your state, from your composable. And there you can see the first example of an animation spec. So if I left this animation spec out, I would have gotten a springy kind of crossfade. But now here I'm saying I want a tween, which is a linear crossfade, and I want its duration to be 2 seconds. So you can see it's quite easy to just wrap any of your other composables in a crossfade. And the other thing to notice here is it's declarative, which is saying if the flag is true, we want this. If it's not, we want that. And we want it to crossfade like that. So now let's look at a slightly more complex example. So here we've got a very hesitant user who can't decide if they want to buy or sell. And so they're clicking buy or they're clicking sell. So it's like a state change. The whole screen is in either state buy or state sell. And now at the bottom here, when they change their mind, this button will change from red to green. But I don't want it to flash red and green because that would make my customer be even more nervous. And so I want this color to change slowly between red and green. And so the thing to notice here is that it's one thing that changes. It's just one color. So I can save that color using those functions that I showed earlier and save it in state and then do the animation with that. And this is on pull request number 5. So I will just show you what the code looks like. So here we have that animate color as state. So this is going to return a state object. And what we're saying is we're saying the target value of this color. If it's a by order, then I want it to be this one color. And if it's a cell order, I want it to be the other color. And this animate color as state will store the state of this, depending on what this is. It will store the value, and it will calculate the interim color values by interpolating between the two colors and return it in the button color. We're using a delegate over here. So we're actually getting the actual color coming out of this. And this will change. The composer will know when the state changes, and then the composer will recompose and allow this color to change. Again, here we see animation spec, which says it's going to be a linear interpolation that's going to last over 1 second. And now we've got this color, and this color is changing. And all we need to do is we have a button, and we just give the button that color. So this button doesn't know anything about the animation. The state and the composer will change the color and then recompose this button because this button color changed over time. Okay, let's look at something slightly more complicated. So here I've got a little pie. I'm drawing a circle outline and an inside circle, and I want to animate how it fills up as the coins are being bought or sold. Let's look at what this would look like. So we're using this animate float as state, which is the same family of methods. And it again will save the value inside the state. And the composer will know about this. And we're just giving it the percentage that we're getting from the backend. So the backend says 10% was sold, 20% was sold, 30% was sold. And we're just updating this. And we're saying it must animate over a second. And as this updates, this will change the current percentage value. And again, now here, the canvas where we're drawing the circle, this part doesn't know anything about animation. It just knows that it should draw the arc with a sweep angle of this percentage. And because this is changed inside the state, the composer will recompose and this part will be redrawn every single time this current percentage changes. So again, to notice, declarative, you just say what you want, and then the composer in the state will take care of the rest. Okay, now what if we want to change two things at the same time? Here we're changing, you can see it's changing orange and black over here, and it's like pulsing the size, and it's also doing this continuously. It's running, repeating, so it doesn't start and stop. So remember I said we had that infinite transition that can remember more than one value and can coordinate them. And this is a remember infinite one, which means it kicks off when the composable starts. And then depending on your animation spec, it will either run once or it can run in a loop. And so this size here, we're just animating a float. We're saying we want to go from 0.5 to 1.5. And the animation spec is an infinite repeatable. So, and here you can see you can even add easing, and this can become even more complicated, this animation spec. And this repeat mode is reversed. So what it's going to do, it's going to go big and then small, and then big and then small, because it's reversing the value. So it's going to go 0.5 to 1.5 and back again. And that's how you get the size pulse. And the color is exactly a similar description. I haven't got the code here. It's just using animate color instead of animate float and the different values over there. And then it's as simple as our text. We just say what the color is and we scale it to what the size is from this float value. So now let's see if we can look at some keyframes. So I use the keyframes to make these text elements loop through a rainbow. So go through all the rainbow colors. And we can see what that looks like. So again, it's an infinite transition because it's looping. And the initial value is this red. The target value is this purple. But if I had set up the animation spec, it would have just gone red and then faded to purple and then faded back to red and faded to purple. Or it's a restart. So it would have gone red, purple, red, purple. But because I wanted to go to all the in-between rainbow colors, I'm setting my animation up as keyframes. I work out what the duration is. I look at how many colors I've got, and I work out what the duration is. And then I just have a for loop here that we're setting up. And the keyframes has an infix operator, this at, and it's just saying that I'm looping through my rainbow. I'm saying I want this color at this interval, and then I'm just incrementing it. So it might be 10, 20, 30, 40, 50, 60, or I think it might be over a second, but you understand what I'm saying. So we're setting these colors, and so the animation will go red to orange, orange to yellow, yellow to green, green to blue, because of these keyframes and the colors at the separate intervals. And again, now this color is being saved in the state. The interim values are being saved in the state. This color changes. The composer knows there's some state change. You just pass this color into the text, and you'll get the color changing in the rainbow sequence on your letter. Okay, so now something even slightly more complicated. I built a modifier, and it has particles. It has a particle system. And if you make it visible, it's going to show all of these particles behind whatever's in the front. Let me see how my time is. I've got a little bit more time. This is the last one. I'll go through this quickly. And the idea was using a modifier means that I can use it on any screen, on any composable. So ordinary data class, a confetto is the single of a confetti. It has two methods, one to make it calculate its next position, and another to actually draw on the screen, either a circle or a rectangle confetti for it with a different color. This is just a normal Kotlin function, nothing fancy here. Then I've got another data class that has a list of these confettis, and it's got some other parameters as well, not important, but the most important thing is this list of these confettis. And then if you say next on this, it can go through each of the confettis and update them. So by calling the next method on them, and then they calculate where they are on the screen. So they can draw like that. And now this is the part that's interesting. I'm making an extension function on modifier called confetti. If I have this composed, it gives me a compose function for each time where that modifier is used. Here, I'm storing this confetti state inside the state so that the composer knows that it needs to redraw if there's a change on this. And then this is, inside this confetti modifier is a launched effect. Now, a launched effect is a side effect, and this particular one will run a coroutine. And what it does is it looks at the state. It says, is the confetti visible or not? If the confetti is visible, then what it does is it gets the milliseconds every single time a frame comes through. It's like the VSync tick that you'll see in the Flutter talk. A frame comes through, and then it can update it. So over here, you can actually update on every frame that you need the confetti to show. And then further down, there's a method called draw behind. What this will do is it will draw whatever you put inside here behind whatever's on the composable. And inside this draw behind, typically you would loop through all the particles and you would call their draw function, because in here you get a draw scope and you can actually draw on the canvas. And so that's just briefly the code to make the confetti modifier. And how would you use it? You would literally just add it as a modifier. So there's a box, and the modifier's got a confetti modifier, and I've got text here. So this is not animating now, but these pieces would float around behind this red text. So we'll just do a final demo quick. On this side is the app without the animations, and here you can see the animations. So you can see there's an animated content. There's my little pie chart animating as it gets updated. And then when it's success, rainbow letters, confetti. And there you can see is the confetti modifier behind the tweet code as well. Okay, so just quickly, the questions we had. Where's the draw loop? Well, it's the composer that decides to recompose, and that will run the code again that does the animations. You can customize the animations with animation spec. You don't have to calculate interim values if you don't want to. There are lots of methods that can help you with that. And how do you trigger it? You change the state, and because the state changes, the composer recomposes and it redraws. And so my impressions are that it's declarative. It's quite easy to add the animations. The defaults are really good for common cases. But if you need to change the graph or change the timing or add any other multiples, they're really easy to tweak. And with that, thanks to my code reviewers, and there's a URL for the repo with all of the examples and more. And now I'm open for questions.
Wow, thanks a lot. I think this was great. I'm already looking forward for the moment I can watch this in a silent minute to implement this in my own app. So thanks a lot. I didn't see any questions so far. Any questions? So let's simply wait like a half a minute. But if we
I'll
don't
go to the next slide, and you can see there are lots of references, and I'll share the slides as well afterwards, so people can have a look.
Yeah, perfect. And I think also on Twitter you're available to the audience.
Oh yeah,
if there are
definitely.
Any questions.
And I'll probably share the slides on Twitter as well, and people can have a look.
Perfect. Yeah, I only saw like people cheering up for Jetpack Compose. So I think they really liked it. Yeah, Mark, for example, said, "I really loved your talk, Maya. Thank you very much." Cool.
Cool.
Okay. Then have a great evening, and we'll proceed to the next speaker. Thanks again. So our next speaker is Xaver Lohmüller, and he's an engineering manager at Scalable Capital. Are you there, Xaver?
I don't know if you can.
Yes.
Yeah. Awesome.
Hi,
I'm in the show.
Cool. Hi.
Hey, everyone.
Hi, Xaver. Yeah, happy to have you here. I was already introducing you as engineering manager at Scalable Capital. Broker Mobile. So Broker Mobile is more or less the section or
pretty much, yeah. So yeah, Scalable Capital is in general an investment or personal finance company, but our biggest product is our broker, and yeah, it's a big chunk of our business, and yeah, I get to be the engineering manager for that team. So
cool.
Yeah.
I won't waste lots of words actually, because yeah, we have not so much time, but as we talked about it before, your first computer was which?
Yeah, it's I don't know, something 86, 386, 286, something like that. I don't remember. It had one of those really cool buttons that said turbo on it, and then everything was faster. And yeah, sometimes I wish my current MacBook would have something like that as well. But
yeah, my parents had one like that, like 60 megahertz, and then you could boost it to 80 or something.
Something like this, yes.
Yeah.
Yeah, old school overclocking.
Yeah. Okay, cool. Then yeah, I will just hand over to you. So you're good to go. Thanks for being here.
Yeah, thanks for having me. And yeah, I hope that I'm now sharing the correct screen. I think you can see my screen now, right? All right. Yeah, I have another About Me slide. Yeah, as Nino already said, my name is Xaver Lohmüller, and I go by Xavier Lohmüller on most socials because that's easier to pronounce for people of an international background. And yeah, like I said, I'm an engineering manager at Scalable Capital, and we're hiring especially Android engineers, but also iOS engineers. So come find me afterwards if you're looking for a new role. And yeah, in general, I'm somebody who really values quality in apps, and yeah, I think that animations can make apps awesome and make for awesome experiences for mobile app users. And yeah, today I'll be speaking about animations in SwiftUI, and we'll be talking about what an animation is really. And yeah, Maya already did a great job of explaining how this works in Jetpack Compose, and in SwiftUI it's very, very similar. And yeah, then I'll show some code examples of like everyday animations that I've already built. And I'll also provide an outlook to advanced topics that I'm not covering in the talk. Yeah, this is more or less a basic talk and shows some pointers then at the end where you can follow up if you want to build some really wicked stuff. So yeah, let's get into it. What is an animation really? So Swift is a language that really, really loves value semantics, and pretty much everything in Swift is a value these days. And Swift UI views, in fact, are also values, like as in having value semantics. So when you copy it, you have two distinct views. And yeah, when we think about views in the classical sense, then we think of a screen or something, or like a little widget or something that can animate and can change, and that really sort of doesn't go well with the copy semantics of value semantics. And yeah, we think of SwiftUI views more of like a description of a view at any point in time. So think of a view that has some sort of text, and now it has this text, and in the next second it has a different text or different values. And then an animation really simply interpolates between two values. So for each frame that is in fact drawn, a new view object is created. This sounds really expensive, but in fact, yeah, sort of SwiftUI takes care of this. And in SwiftUI, animations are always based on some underlying state, and this is like the best feature. And I think it's very similar in Jetpack Compose, because you have a single source of truth on which everything is based, and this makes them interactive. And if you've tried to make an animation interactive with an object-oriented or procedural framework before, then yeah, you know that it's very easy to get them out of sync and yeah, sort of have a different animation state, and the underlying state is different, and yeah, it's just a mess. And in SwiftUI, we have two moving parts when we're dealing with animations. And one of them is sort of the underlying state, or yeah, the data. And for that, we have a protocol which is sort of like an interface in Java, which is Animatable Data. And the second part is a timing curve, pretty much, and that's what we call an animation. But it's not really what we think of, like flashy lights moving around the screen, but it's in fact just a timing curve. So I think it's a bit of a misnomer, but it sort of makes sense. All right, and animatable data is something that is sort of a vector, so something that you can interpolate between. So pretty much any floating point number. So when you animate a piece of state from 1 to 10 or something, or other things that are based on floating points, such as CG size or CG point, or which is like geometry primitives. And you can also have manual compositions of them, like animatable pair, and then you can have a composition between a floating point number and a Boolean, for instance, that then get animated at the same time. Or you can have really, really complex custom types, and those are ones that conform to vector arithmetic. And I'll show you one that I've built for scalable in the practical section. And yeah, that's really cool to conform to vector arithmetic, but I'll show you then. So animatable data basically is any piece of state that is part of the view. So in this case, it would be like the current step. So I have a progress view that goes from 2 to 5 items, and I can animate over this piece of state. And then when I, for instance, change from current step 2 to current step 3, what Swift UI basically does behind the scenes is it creates for every single frame a new instance of this progress view struct with sort of the current progress in between. And based on that, you draw your view then. And I'll show you in a moment in the practical example as well. And the second part of an animation is the actual animation. But like I said, this is simply a timing curve. And yeah, there's a few built-in ones, such as like default, which is an ease in out. So it starts a bit slow, then moves faster, and then at the end, it slows down a bit. Like, for example, you would drive a car or something. You don't start with the full speed and stop with the full speed, but sort of gracefully. And those animations also compose. Like, you can repeat them, you can start them again, you can add different curves to them. And yeah, basically every time you have an animation, you compose your custom animation curve. And yeah, the classical ones are linear and ease in out. And really popular is also the spring, which we also saw in Jetpack Compose with the beautiful drawings on the slides of Maya. And like I said, we can compose them by just chaining on more animations. And yeah, let's go to the action now. Is this big enough for everybody to read, I think? Should be good, right? Maybe I can do a little bit more. So what we have here is a fairly small Swift UI view. So we have this text box that we can see here, and we have a button at the bottom, and yeah, it says animate. And when I tap on that button, it will take this animation state and just toggle the bool from false to true. And this text box then is dependent on the animation state. And basically, if the animation state is true, it will have an offset. And if it's false, then it will have no offset. So that's the first ingredient in making a Swift UI animation. So you have some sort of state that you want to animate over. And now when I tap animate here, it will flip the bool and basically add the offset. And when I do, you can see there's no animation happening right now because I did not specify a timing curve yet. But I can do this really quick. And now when I do this, basically the animation is there. And here I'm using the interpolating spring with a speed up of 5. Because the thing is with the spring animation, it's a physics simulation basically, and you cannot say beforehand how long it will take. But in this case, I've measured it, and it sort of takes 5 seconds, and then I do the speed modifier to speed it up, like to play back 5 times faster than it usually would. So in the end, it's about a 1 second animation. And now I'd like to maybe take this out, and now it animates really slowly. And I just want to appreciate for a moment how awesome it is that we have these interactive animations. So basically, when I tap this multiple times, the animation just stops in the middle and just reverses at any point in time. And yeah, this is sort of really hard and impossible to implement with UIKit. But now it's with Swift UI, basically, it's easy and the default. And right now I'm animating only over this offset. So yeah, X position basically, but it's easy to just add different things here. So now I'm adding a rotation effect. And this one also depends on the animation state. And now when I tap here, then it will add this animation, this rotation effect. So you can just have multiple things that you want to animate over all at once. And also, like, this is interactive, so yeah, I wouldn't know how to implement this if it wasn't magically inside of the framework. All right. Another thing I want to show you is, yeah, 90s kids will remember this. So when I got my first iPhone, to unlock it, I had to do the slide to unlock thing. And yeah, I sort of thought it would be cool to have this in SwiftUI as well. And yeah, let's see what we do here. So this time our animation is a linear animation. Yeah, it doesn't start or stop at the end. And there's a delay of 1 second. So you can see that like it slides over and then it stops for 1 second and then it starts over again. So yeah, and then also it's repeat forever, because yeah, at some point the user will start to slide to unlock, but until then we want to nudge him or them to in fact do the sliding. Maybe to show how this is built, basically, oops, that was the wrong hotkey, like this. So what I'm doing here is, in fact, I have this linear gradient. That's this white thing in the middle, and then I stamp it to the content, which is in this case the text slide to unlock. And one important piece that Maya mentioned that I haven't so far, every animation sort of has to have an starting point. So oh no, this one. So here it was easy to see that the animation would start when I do the button tap. So this button tap sets the animation in motion and starts things. But for the slide to unlock thing here, I don't have a button to start it, and it would sort of be silly to ask the user to start the animation in this case. But what you can do is you can have this on appear modifier, and basically this one is called when you put the view on the screen for the first time, and yeah, this one sets the position from 0 to 1. So I'm thinking of like this of progress, in terms of progress, so from 0 to 100%. And yeah, this one starts the animation, and the repeat forever modifier basically keeps it going forever. Yeah, so those are like everyday animations that I use frequently in my code. And one thing that I want to show you now is something that I'm working on. I unfortunately cannot show you the source code because it's closed source and from our app. But this is a view. So when you want to invest with us, and you sort of can specify like how many years, and we then show you like how your money will behave in the future, like in 5 years time, in 15 years, in 20 years, and so on. And this view here is very complex. Like it's a chart with hundreds and hundreds of data points. And yeah, basically the animation was for free because I conformed this model object to the vector arithmetic that I mentioned earlier. And it does all of this stuff by itself. And I wouldn't even know how to animate stuff like this, but yeah, it's sort of magically happens under the hood for me, because all I did was implement this vector arithmetic. And vector arithmetic is a protocol basically that all vectors have. So if you think about math class back in the day, you with vectors, you sort of have a zero vector, you have a way to add vectors, and you have a way to subtract vectors. And also you can scale them by a factor, so make them longer or shorter. And I think that's the thing that SwiftUI does to animate stuff. And also then there's the dot product. I'm not sure why you have to implement this, but yeah, it sort of belongs to a vector. And once you do that, basically, then you get all this animation goodness for free. And yeah, you sort of have to think about like, what does it mean to add two charts together. But once you figure it out, then you get this animation. Okay, yeah, basically those were the basics. I want to now shout out some websites that I used for research, but I cannot really explain here. So one of the things is that is new is this timeline view. So this is something when you need further control over your timing curve. Like, I don't know, you have a 5-second animation and after 2 seconds you do something completely different. Then you would use a timeline view, and they used it here in this example to implement a metronome. Like, so the timeline view goes 5 seconds in one direction and then turns around, for example. And this one pairs also with the canvas in SwiftUI, which they use to build this matrix digital rain here. And the canvas is sort of, yeah, a step forward and a step back at the same time, because in SwiftUI basically everything is declarative, but sometimes you want to have imperative drawing API, and that's what the canvas is for. And this is also a good way to do really complex animations, especially paired with the timing curve. Another thing that people do is like build progress indicators, like, or loading indicators or something, and then you animate stuff over a path. And yeah, that's also really hard. But yeah, you can read how they did it in this blog post. And in general, I want to shout out Meng To. He's like one of the really masters of SwiftUI and design. Like, he's a developer and a designer at the same time, and I don't know how he does it. But yeah, he really pushes SwiftUI to the edge. And yeah, in his courses, you can read about really advanced animations, and like, if when lots of views interact, then how you can animate those in a nice way. All right, and that's almost all. So, oh yeah, those are my notes that I used. So there's great books on the topic as well that you can find. I'll send out the slides after. And yeah, that's it. Thanks.
Great, thanks. So this was a good insight into SwiftUI, also for beginners like me. And I really appreciate all the talk, and also I like the API as well. Mark also gave a shout out to this API. So yeah, I also didn't see any questions so far, but we'll do it the same like with Maya. You will post these slides on Twitter, right? And then available for any further questions on Twitter as well.
Yep, sure. Feel free to hit me up. And
thanks
yeah,
again.
Forward.
Yeah.
Thanks for having me, Nino.
Yeah, you're welcome. Have a good evening. Bye.
See ya.
All right. Then I hope that we'll be able to advance to the next speaker, which is Dominic Koskovsky. The Flutter community might already know him. Dominic, are you there already?
Yes, I am. Can you hear me? Yeah.
Hey,
hi there, everybody.
cool.
Good to be here. Finally with you guys. Super happy to be here.
Cool. Yeah, we are also happy. Thanks. Let me say some quick words about you for those who don't know you yet. You're a Flutter GDE. You're working as a Flutter engineer at Very Good Ventures. And most importantly for me, my personal opinion, you're a co-founder of Flutter Europe.
Yeah, cool stuff.
Yeah, I actually, the last in-person conference I attended, and it was super great. Is there part 2 planned or a second one planned?
That's a tough question. I wish we would have bandwidth and the team to build a new Flutter Europe conference. We'll see how it goes. Unfortunately, the pandemic and all the changes in the world forced us to not continue with that. But definitely, there will be more events. There will be more conferences. And hopefully, as soon as the pandemic situation settles, we should be able to have something close to the Central Europe, right? Maybe Germany, maybe Poland. I hope that we will see something bigger than just I don't know, like a local meetup, something that could actually collect the Flutter community around the world.
Yeah, great. I also think that Flutter Vikings is already in person and in person.
Yeah, it
event,
will be
so,
in September in Oslo.
But I'm also looking forward to something here, like a bit nearer in Germany. Okay, but having that said, I will just hand over to you. Yeah.
Awesome. So I'm gonna share my screen. So if you could just quickly switch to my screen. And let me see if you see this. Yeah, you see. So yeah, I'm super happy to be here with you all. I know that there are hundreds of you right now listening to me, so that's super cool. And actually, I wanted to also give a big shout out to the previous speakers and their great presentations. And it's awesome to see like how vibrant and diverse the animations can be across different approaches. And so I got actually introduced. I'm an engineer, a Flutter engineer, and actually one of the things that really pulled me into Flutter was how easy it was to build the UI, the animations, this kind of stuff. Before that, I worked with Xamarin, with native Android, and a bit with native iOS, and it was never so easy as it was in Flutter. So maybe today, after this presentation, you will get some more insight how to build this kind of tools. So this is a shameless plug. If you're looking for a Flutter job, we're hiring also in Europe. But again, I think we can move on to the main topic, which is animations. And like we saw some cool animations in last hour. And as you can see, like we always need to build animations. They are either little micro interactions that we have, for instance, when you mark your to-do list as done, or they can be super complicated, like in the Reflectly app, where the whole app is actually just a big complex animation. And today we're going to start small in our exploration of how animations work in Flutter. And then at the end, we have a little bit more complex stuff just to give you some maybe inspiration for your own projects. When we talk about animations, we say about implicit or explicit, or intrinsic and extrinsic, right? There's like a couple of different approaches, but the main difference is that implicit animations are the ones that just happen without any kind of driver, right? You press a button, something changes, and the animation runs, and you don't need to control like that it needs to start right now, it needs to end in 2 seconds or whatever. It just happens implicitly. And explicit animations are the ones that you need to drive on your own in some way or the other. So typically, explicit animations would be driven by animation controller, which is like the special class in Flutter. But you can also use some other means for that, like timers or just some kind of change notifiers. There is a lot of options that are available to you. And implicit animations are, as I said, are the ones that are actually happening on their own, right? So you, for instance, click on a button, some state changes, and the animation runs, and it interpolates from one point to the other. In this case, you can see a button, and it just changes some properties, right? It changes colors, it changes size, radius, border, and so on. And actually, you can try for yourself the demo application that I've prepared for this talk. It's under roshkovsky.dev/animations. So if you go to this address, you should be able to see the application that I prepared. So hopefully you see now that I have this app running right now. This is running on Mac OS, so this is a desktop application, but it also runs just fine on mobile and web, because Flutter runs on all of these platforms. Let me just make sure that you have, you saw this. So sorry about the infinity mirror effect, but I needed to make sure that you all can see what I'm showing. So here, if you press on the button, you will see that it animates. And really cool thing about Flutter is that there's myriad of different widgets that you can use, and many of them have this animated variants. So you have container which is just a box with some properties. And you can add a prefix animated, and there is a variant of this that just whenever you change its properties and rebuild the widget, it will just animate implicitly. And here you can see the opacity that changes, right? And here is a really interesting thing, and this could be like even a question to you guys. Do you even know what this is used for? So there's animated physical model, and this is a thing that's pretty cool. And probably as a developer, you would never use it, but actually you use it all the time. Every time you have some elevation in your app, you're using the animated physical model deep in the widget tree of your application. And the same happens with, for instance, animated align. So there is align widget by default, and you can also use animated align. So whenever the alignment of this widget changes, it just smoothly animates from one point to the other. And this is pretty cool because you don't have to implement any animation whatsoever to make this effect. However, sometimes it's not enough, right? You may have to animate something that's not included by default in Flutter, and maybe there is no good library to use to have this kind of animation. And here's where implicitly animated widgets come handy. And in this case, what I've done is to have this circular progress indicator to animate between steps. By default, when you set a circular progress indicator to a value, let's say 0, 0, and then you change it to 0, 1, it just changes rapidly from one value to the other. However, you may want to have a bit more fluid motion, maybe when you have a download or upload in your app. So this is where I created the like a fluid or smooth circular progress indicator. And actually, you can create the same thing for like a widget, but also for the text or the double value that you have for your progress. And the nice thing is that it will be interpolated by using the implicitly animated widget. So let's see how you can create your own implicitly animated widget. This is not much harder than any of the stateful widgets that you would create in Flutter. Just to give you a quick introduction, there are stateless and stateful widgets. Stateless widgets are just rendered and nothing happens with them, actually. They just are a description of the UI. And you may know that in Flutter, we have like a widget tree where each of the widgets can have a single child or more children, and you describe them using this pretty convenient syntax. And there are also stateful widgets, and they can hold state between rebuilds. And implicitly animated widget is like an extension of a stateful widget in a way that first you have to define the API for your widget. And this is just a smooth loading indicator. And we have the, let me make this to laser pointer. You have the some properties like a progress, the current progress, the duration between changes, the curve that we are going to use to interpolate that, and the color and maybe background color. And these fields are stored here. And we're extending the implicitly animated widget similarly as we would extend stateful widget. The other part is the animated widget base state. So state is like a base state for a stateful widget. Pretty similar structure. Here we have our build method, and build method in Flutter is a place where you actually tell Flutter what it needs to render. And here we have our circular progress indicator. This is a built-in widget into Flutter's material library. We have some properties, background color and color. So we just define these colors. And then we have like a tricky thing where we call, we have this tween here, and we're going to talk about tweens in a second. But tween is just a class that allows us to interpolate between two different values. I think in a Jetpack Compose talk, you also were mentioned about tweens, and this is a very similar concept. So we have this tween, and on the tween, we can evaluate our animation, and the animation is provided for us from the animated widget base state. And then we have the special method called for each tween that we need to override. So the animated widget base state of smooth loading indicator exposes for us this method for each tween, and we have to override this so that every time when you build this widget with a different value of progress, and progress can be 0, 0, 1, 0, 2, and so on and so forth, any double value, we have to call this value and this method and this build code. Then there's another method that is exposed by animated widget base state that we just need to call with some properties. Progress is the current value of this tween, right? It can be null at the beginning, right? So first it can be null. Then we have some target value, and target value is widget progress. So if you go back to the previous page, here is this progress value that we used. So in the next, we just refer to the progress value. What I do here is that I just clamp this value so that it's never below 0 or above 1, but it's just a standardization technique for the data. And then we have the callback that will define the tween. Tween is a technique that allows us to, or a class that allows us to interpolate from one value to the other. And actually what we do here is we just tell what kind of tween this animated widget-based state need to use, and it will just use a linear tween where the value previous and the next one will be interpolated linearly. So if your previous value was 0, 0, then the next value is 0, 2, then this difference will be interpolated linearly. So let me show you again how it works. Right. So here we have this, and we just, when we click, the value increases by 0, and it just linearly interpolates. If you want to see like the real code for that, you can just go to the GitHub repository. So if you open this on a website, you will see the source code here. And if you press on that, you will be navigated to the GitHub repository. And here we have the smooth loading indicator implementation. So as you saw, we have this for each tween method. And the same, if you have the just text value, the structure is exactly the same, with just exception that instead of rendering the circular progress indicator, now we are just rendering text, right? So we have a text, and it just has some styling, and we just format the string appropriately. But in practice, this method is exactly the same as the previous one, and this way we have this nice smooth loading. The next, I would say, so this is just a recap, right? And the implicitly animated widget is useful when you know that you just need to animate between two basic states, but there is no built-in widget into Flutter. However, sometimes implicit animations are just not enough, and this is where you want to use the explicit animations. Explicit animations are where you need to drive them in some way. And typically, you would use the animation controller as the engine for your animations. I mean engine in a way that it will tell you how fast or like when do you need to run every new frame of your animation. And with the animation controller, you can use some kind of built-in widgets like scale transition, size transition, fade transition, or like the best of all of them is animated widget, which all of them will just use the animation controller to be aware when they actually need to rebuild the underlying widget, because you don't want to rebuild your widgets constantly. You just want to rebuild them when it's actually needed. So for instance, when a new frame needs to be rendered and the value of the animation changes. And in my sample application, you can see some of the explicitly animated widgets. They are not implicitly animated widgets, right? So for instance, this Slack logo or this loading indicator or this are all driven by some animation controller or some other mean. So if you go to the source code, you will see some examples of that in the explicit animation section, right? So you should be able to just investigate. However, today we're just going to focus on this little icon that we see on the bottom left. And let's see how you can easily implement this kind of animation in Flutter. Basic stuff, we just have an icon and oscillating border around it. And this just, it can be used to indicate to the user, hey, click me. And in this case, we are going to use our friend stateful widget. And stateful widget, in this case, we don't have any kind of API for that because it's like a self-contained. So we just need to focus on the state of a stateful widget. So here we have just a create state, and we have this class called animated radiating icon state. Important part is that aside from having just the state extending the class, we also need to provide it with a mixin called ticker provider state mixin. Mixins are special Dart feature that allow you to just extend or mix into your class some other features from different classes. In this case, ticker provider state mixin, as the name tells us, will provide us with a ticker. And we're going to talk about ticker in a second. So in our state, we just need to maintain the instance of our animation controller. And in the special method called init state, we have to instantiate this. So what we do is that we first need to call the super, and then we have the animation controller constructor. We pass the vsync. And if you work with any animation toolkit, you will probably recall the vsync. Vsync is like a thing to tell us when the new frame gets rendered. And in this case, we just pass this because our class is actually providing the ticker provider state mixin. Then we just define some duration. The nice thing about the animation controller is that it exposes some useful methods. And in our case, we have the method forward, which will play the animation. And then we have the repeat with a parameter reverse equal to true, which will cause this animation to loop indefinitely to perpetuity, right? Important part about the animation controllers is to dispose them when your widget gets disposed, because we don't want this callbacks from the animation controller to run all the time. Then, of course, we need to render our UI. So the state of our widget will also have a build method. And in this build method, we will use our super cool widget called Animatedbuilder. The nice thing about the Animatedbuilder is that it will build its child only once, right? So this icon button that we have here will be built only once when this gets rendered. And then our builder actually will be rebuilt every time the animation controller will tell us that a new frame needs to be rendered. And what will happen here is that we have just some kind of decoration, and then we have the padding. And actually what I do here for this particular animation is that I'm just changing the padding around this icon button from 0 to 8. So the animation controller value will oscillate between 0 and 1, 0 and 1, 0 and 1, and so forth. And I just multiply this by the value of the padding that I want to have. And this way, I just oscillate with the padding around the icon. And this way, I have this nice oscillating motion. And there are many ways to implement this kind of animation. It doesn't have to be padding. It can be just a circle below that increases in size. It can be a border that increases in size. But this is nice to show that you can actually split your animated builder into two parts. The first part being the decorated box with the padding, and then the decorated box with the icon button, which will be rendered only once, built only once, sorry. Yeah, and tweens. Tweens is a concept that's showing up in animation techniques all the time. And actually, it came from the typical old-fashioned animation techniques, and its source, its name comes from the in-betweening technique in the animation. If you watch some old Donald Duck or Hanna-Barbera cartoons, you remember that maybe the characters actually, when they were running or moving, they were not drawn as they were like in reality, or like they were a little bit blurred. And this technique of blurring the character is called in-betweening. And this was, for instance, used by Pixar or some other studios also digitally. And this is how tweens came also to the typical animation frameworks. And it also lands in Flutter. So in practice, tweening or tweens are used to interpolate or map and interpolate from one value to the other. So for instance, as I said a couple of minutes ago, animation controller will only have values between 0 and 1 unless you unbound it. But typically, the animation controller will be between 0 and 1. But if you have some values that are not 0 and 1, or maybe they are not linear, maybe you will have to like from 0 to 200 and then maybe to 500 or whatever. Or maybe you don't even have integers, but you have maybe some custom classes that need to be interpolated. You will usually use tweens. And tweens, for instance, they are generic, so we can provide any in any class that can be linearly interpolated, it needs to implement lerp method. So for instance, offset does, because offset actually is just a class containing two integers, x and y. So in this case, this tween will interpolate and map the value from offset 150 to offset 200, 300. And it will be a linear interpolation from 0 to 1. And you can use tweens in two ways. And I found that this is pretty confusing because once you read one tutorial and they use this syntax, other times they use this tutorial and use this syntax. And practically, this is equivalent. When you have animation controller, you can just call a drive method and pass a tween, and you will receive animation object, right? So we have animation controller. When you apply a tween, you will get animation object, or you can have a tween class, and you can animate that with your animation controller, and then you also get the animation object. So both ways, exactly the same effect. And so I mentioned that tweens are typically or by default using linear interpolation. And however, you can chain or extend a tween so that it doesn't use just the linear curve. So in the example application, if you go to the tweens section, you will notice that there is several different examples what kind of curves are included in Flutter that make your life a little bit easier. So if you have any kind of motion in your app, you will probably use some curve. You will not make the movement linear because in reality, not many things in nature or even in app development behave linearly. So for instance, maybe you will use the decelerate curve, or maybe you will use ease in out when you show something on the screen. And with tweens, you can do this in very easy way. Like here, you can see one simple case where we have a tween class, and then we animate this with curved animation, and we just apply some curve that we passed in. This curve can be any curve. There are some built-in in Flutter, but you can, for instance, get the curve definition from your designer, and you just put some points, and you have a curve that will describe how the movement looks like. So pretty cool stuff, and you can also chain multiple curves. So you can imagine that maybe you want to have sinusoidal curve multiplied by the ease in or whatever, and you can just chain them indefinitely so that you arrive to your desired movement definition. Then we have another pretty handy thing, which is the Tween Animation Builder. And Tween Animation Builder is a really nice thing that allows us to combine some benefits of implicit animations and tweens. So what happens here is that the Tween Animation Builder, and this is the code that I used to implement this, have some really nice API that hides some complexity of animation controller. You remember I said that if you have some complex animation, you may need to use animation controller, but sometimes you can really save some time by using the Tween Animation Builder. Because similarly to Animatedbuilder, it has a child and a builder, and child will be only built once, and the builder will only be when the Tween Animation Builder built-in animation controller will tell it to do. What you do here is that you define the duration, you define the tween that you want to apply. In this case, I just applied linear tween of 0 to 1, 0. And I can also apply a curve. So this curve will be chained onto my tween so that I don't have to manually create the tween with a dedicated curve. So really nice, like API that explicitly says, what do you want to achieve? You can skip this. You can maybe make the duration different and so on and so forth. What I'm doing here actually is that I'm using the transform.scale. And the nice thing about the Tween Animation Builder is that it will remember its most recent value. What I mean by that, if you go back to the screen and I will go back from here to here, you will see that this text actually scaled from 0 to 1, right? So now this is in the scale 1x. And now I will scale this to 10x. And now I will scale this to 30x. So you remember this movement, this interpolation starts from the previous value. And this is cool stuff because now you can have some kind of stepped animations happening depending on the previous value. And this is super cool because you don't have to maintain this previous value on your own. It will be this widget that actually will hold the reference. And this is actually, if you even change this during the animation, it will just stop and change its direction really nicely because it's a mutable object and you can just change it as you go. Pretty cool stuff, really powerful, but at the same time, super simple in terms of the API. Highly recommend. So all of these things that I've mentioned so far are like super built-in, available for you, maybe aside from the implicitly animated widget where you have to implement it for your own. However, sometimes you have to go a level lower in your animation control. And here's where the ticker provider and ticker are handy. Come handy. So what I do here is that I have some simulation, and let me show you this in practice. How does it look like? So I have my custom controller page, and here I have some voids simulation. So these are a flock of birds, and I can just increase its number, and I can make them faster, slower, or whatever. And this is just a mathematical simulation trying to show how birds can fly in flocks. Really basic stuff. And in order to do this, I had to use something more than just animation controller. So what I've done is that I used Change Notifier. And Change Notifier has this nice ability to call notify listeners, and then any listener, for instance, Animatedbuilder, that listens to this class will be notified that, hey, you need to rebuild yourself. And you remember that in the case of animation controller, we were passing the vsync, and this, in order to make this API similar, I also named this vsync. So vsync in our case is just a ticker provider. You remember single ticker provider state mixin or ticker provider state mixin. We just pass here this class that will tell us when a new frame gets built by Flutter. So what I have here is that I'm assigning the ticker value, ticker variable, by calling create ticker on our vsync or on our ticker provider, and then I'm passing the callback on each tick. Here our on each tick, and then I'm just calling start. So I'm telling this ticker, hey, now start ticking, and every tick I will be notified here. And tick is just a frame, and you will get an information from Flutter how much time has passed since your last frame. And this is a simple mathematical information or formula to tell you, for instance, how far your bird has flown in this like 2 milliseconds between each frame, or 4 milliseconds, right? And you have some time between each frame to make some calculations, to make some data manipulation, this sort of stuff. So what is happening actually in the simulation of birds, they are iterating for each of the birds and just calculating how should they fly, right? And I can just change some properties to make them faster or slower. And actually, the full implementation is here available. If you go, I don't remember the exact file name, but if you go to the voids, yeah. So here, if you go to the custom controller file, you will see the voids animation, and there's the full code that I used. There's a custom painter that I used here, and some definition of our void simulation. So here you can see the change notifier that I used, the exact same code to create a ticker. And the nice thing about the ticker and ticker provider is that it will tell me exactly when a new frame gets rendered. And if you want to have, for instance, 120 frames, you have to have at least 8 milliseconds between each frame so that it remains fluent. Let me see how much time do I have left. I see that there are some comments. Sorry about showing this in this form, but I have only one screen today. So the change notifier can be used in our animated builder, and this is really handy. You don't have to use change notifier. You can use any class that can trigger a rebuild. So it could be even a block or a state notifier or Redux store or whatever that will just tell you that you have to render a new frame. So this is pretty cool stuff because you actually went pretty low level in your animation implementation. I think a bit lower level would be on the widget layer if you would try to use render boxes or render objects, this kind of stuff. But here we just used custom painters. Just to recap, ticker provider and ticker are the classes that can help you if you need to create a really low-level custom animation that requires from you some more control over how much time passes between each frames. Maybe you have to do some more elaborate computations in between. Just to finish our presentation, I'm going to show you some simple, I would say, built-in gadgets in Flutter. So Flutter comes with some simple physics simulations, and one of them is spring simulation. If you had physics in high school, then maybe you remember like a spring equation. And in practice, this is what is happening here. We have our spring description where we have mass, stiffness, and damping, initial value, end value, and the velocity. And we just can use animation controller to run this simulation. And the nice thing is that there is also some other simulation, gravity, friction, scroll spring, and Flutter is using all of them in some way or the other. For instance, to make some kind of nice UI behavior. And if you go to the demo app, you will see that there is like this basic spring simulation, but there is also a gravity simulation. And this is, again, very simple mathematical formula. But the nice thing about Flutter is that it comes with that included, and you can also create your own simulation. This is pretty cool stuff. If you, for instance, want to make some kind of simple game or some physics-like behavior in your app, and you don't want to, I don't know, like calculate all of that stuff manually, and you can just use some nice APIs for animations that are included with Flutter. Let's recap. We have a lot of implicitly animated widgets, like a myriad, ton of different widgets that you can use. However, sometimes they are not enough. You can use your custom implicitly animated widgets, but you can also use the animation controller. And frankly, don't hesitate to use one. Like, it's pretty, I would say, intimidating at the beginning, but as you start using the animation controller, you should be good to build almost anything you like. Sometimes it's enough just to use the Tween Animation Builder. It's fine, and then your API can remain a little bit simpler, but you don't have so much control as you would have with the animation controller. If you want to go really low level, you can go with the ticker provider. And for instance, in my case, I went with the change notifier to make sure that my widgets get rebuilt every time my ticker provider tells me that the new frame is rendering. And if you want, you can simulate some physics behavior with some built-in spring simulation, gravity simulation, or you can create your own by just implementing the interface. That will be all for today. However, if you want to learn more, there's so many awesome resources to watch, to read in the internet. This presentation is available also in the repo. So if you go there, you will find all of these links. And as you may notice, I haven't used any package. All of the things that I shown were vanilla Flutter, nothing outside of Flutter. However, some people prefer to use packages. I'm not one of them, but you can use some packages that come with really nice simplifications for the animation. So there are simple animations, animator, blah, blah, and so more. So if you're into more like maybe bigger number of animations and the included APIs are not enough for you, this can also be a good way to make it even easier. Yeah, that's all from me. I wonder if you have any questions to me. It was really cool to be able to share it with you. So yeah, I'm looking for any questions if you have some.
Thanks for this talk again. So already packed with lots of information. I also didn't see any question in the chat so far. What do you say about like 10 minutes, 5 minutes, a little panel about the similarities between those three talks? Are you in,
Yeah.
Dominic?
Yeah, awesome. Yeah,
cool.
Let's do it.
So come in, all the others.
Hey, I sort of have a question, but I don't know how I probably need to sign up or something. but yeah, I can ask you right here now. So I saw that you had animated text in your presentation. Is that something that does Flutter out of the box, or yeah, how did you do that?
Yeah, so there are, I would say, two things that you need to be aware when animating text in Flutter. So there is just the text itself, right? Like the letters or numbers. And there's also the style of text. And by default, the style won't be animated if you change some styles. If you change a color from green to yellow, it will just abruptly change. However, if you use, again, something that has a proper prefix, which is called default animated text style, right? So there's a lot of conventions in Flutter where you just prepend a name with animated, and magically you have something that animates itself. And then if you change from one style to the other, maybe from black to red, it will try to interpolate between two colors or maybe between two sizes, right? So this is on the styling level. If you talk about the content, then it's something that you need to do on your own, as I've done. So I just had a double value or integer value that I was just converting to string. So I was actually interpolating the integer, and then I was just showing this on the screen as a string. But that it was not that the string was animated; it was just its integer value.
Cool.
But cool question. Yeah.
Did you find any other similarities between your talks? Maya, you already had like a little similarity. Confetti.
Yeah.
And voids.
Yeah, the one thing I noticed that a tween is not a tween, right?
Yeah, the naming is a bit different, right?
Yeah, so your tween is my animation spec, and your curve is one example is a tween for me.
Yeah, like I would say it's like a fluid naming, right? Convention. Some folks tend to name tween just as very specific thing, like linear interpolation. Whereas if you have a tween, you can extend this also with a bit more elaborate curves to make it a bit more complex animations. It can be confusing here, yeah, if you move from one technology to the other, but also by having three different technologies, and actually if you even have some background maybe in the UI design, you will definitely be in the same, I would say, area, right? All of these things will seem similar. Now, of course, with the you will have to be aware of some kind of naming differences, and maybe you will try to instantiate some class and there will not be there, but there will be something similar that will have the same behavior, but just a little bit different name.
Yeah, so all three of the platforms have a way to make a graph, have a way to have like a sinusoidal or with easing or whatever. It's available in all three of the platforms.
And also, we really like to drive our animations off of states. So that's what the toolkits do.
Yeah, definitely.
Days.
This is something that like actually changed in the last couple of years. I don't know if you remember a couple of years ago when you want to do an animation. I think only iOS had this opportunity to like, here's the end state, right, that I want to achieve, right? In iOS, it was possible to have this kind of animation, and it was iOS that actually was interpolating that. And now we have Jetpack, Compose, we have Flutter, we have Swift UI. If you're a web developer, you will also find similar tools that just give you this reactive API for animations, or like a declarative API for animations. Here's my state A, here's my state B. Let the engine do the hard work for me for interpolating that.
Yeah,
and then, sorry, go.
I just wanted to say that that's something that I love so much because it can never go out of sync. But yeah, I said that like 10 times during my talk, probably.
Yeah. So for me, the cool thing is also that Compose will optimize. If it knows it's just the red color of my button that's changing, it won't recall all of the recompose the other composables. It will only change. So I'm assuming the other platforms have a similar mechanism.
Same here. And the nice thing is, if you run your animations like a couple of more times, the compiler itself, or like the code itself, will optimize so that it will be even smoother. This is very valuable, especially in the debug mode, where you like the first run can be a little bit clunky or junky, and then it optimizes itself, and this optimized version sometimes can even be better than the compiled version, right? So it's pretty cool stuff. And however, like, I wanted to point out one thing, which is, I don't want to be like a bad messenger, but in Flutter we have this issue with shaders. And this is something that every developer that does iOS animations with Flutter needs to be aware of. Because with iOS switching from OpenGL to Metal, I think like 2 years ago or something, there was a lot of problems with shaders. So if you use SwiftUI, usually you're good to go and all the animations should be fine. However, if you use something like Unity or in Flutter we use Skia, then the shader thing can be sometimes tricky. And the bad part with that is that you are never certain what kind of shaders do you need for your animations. If the animation is simple, then the shaders will be super fast to compile. But if the animation is a bit more complex, maybe involves some opacity changes, maybe some shade or whatever, then it sometimes one pass of an animation is not enough to generate a proper shader. And you can have like a situation where your animation runs 1, 2, 3, 4 times and it's still junky. And this is where in some cases you have to employ some techniques to generate the shaders even before you deploy your app to the App Store. So you essentially have to run the animation first on the device like 5 times or something. All the shaders get cached, and then you have to supply these shaders into your application as some additional binaries just in your library, so that when the app is run, it doesn't actually have to generate the shaders in runtime. It actually can reuse the generated shaders. There are techniques to use that, but if you're using SwiftUI, usually just Apple took care of you and you don't have to do it.
Oh, don't worry. We have our crazy jarring bugs as well.
Cool. Any more questions? Any more similarities you three want to talk about? Or
I think it's awesome that we all love animations and we can work in completely different technologies.
That's a perfect. Actually, I wanted to say something similar for the ending, so I will do that right now. We crossed lots of borders right now. Tonight, we crossed technology borders, we crossed country borders. Yeah, we are here from Poland, Germany, South Africa. We all have the same passion, and that's what I really love about meetups like this. We also have had an audience from many countries, so yeah. Happy that we did this thing, and I hope that this community also keeps this in mind, that there are no borders, that we can always cross any borders, and I hope to see you again. Thanks for joining,
awesome.
everyone.
Thanks a lot. See you soon in real life. Thanks.
Bye.
Thanks for hosting,
Thank
Nino.
you.
This was cool.
Thanks
Great
for
event.
hosting.
You're
It was
welcome.
cool. It
Bye.
was great.
Thank you.
Bye.